Lesson 5 is all about limits and continuity. So remember, continuity is when a function is continuous if its graph can be drawn without lifting a pencil from the page. There are basically two types. So one's called removable, one's called non-removable. So if you have seen all of these types before, we're just separating them into two categories. So removable refers to a point discontinuity, so when there's just a point missing. Non-removable is your asymptotic and your jump discontinuities. So I want you to start thinking of limits and continuities as limits exist if the function approaches the same value from either side. So think of it like a bridge. If the road in and road out meet at that same point, then the bridge is coming together. If they're not meeting at that same point, then it's not going to be continuous because you would have to like fly to get to the other side. So there's three things we're going to have to check to figure out if a function is continuous at x equals a number. So the first thing we're going to check is that f of a is a real number. So that's when we plug in whatever x is approaching or whatever our x value is into our equation and we get a real number out. If it's undefined, then it does not work. The second one is seeing if the limit exists. So we have to make sure the left side and right side are the same. So if the limit exists, that's the other checkpoint. Step 3 is saying, well, if the limit and f of a are the same number, then it's continuous. If the limit and f of a are not the same number, then it's not continuous. So we're going to try two examples together, and then I'm going to let you try C on your own. So starting with A, it says determine whether the function f of x equals 2x plus 1 over 2x squared minus x minus 1 is continuous. And the first one says at 2. So according to my checklist, I need three things. The first one I need to do is complete f of 2. So when f of 2 is basically I just plugging in a 2 for all my x values. So this would turn into 2 times 2 plus 1 over 2 times 2 squared minus 2 minus 1. And if you're wondering where I'm getting those numbers from, that is just your function up here. So I just plugged in a 2 for every x value I saw. Now I'm going to simplify. So 2 times 2 would give me 4. 2 squared is 4. 4 times 2 would give me 8 minus 2 minus 1. So 4 plus 1 is 5. 8 minus 2 minus 1 is also 5. So I would get f of 2 equals 1. So that's condition 1. Condition 2 is now I got to look at that limit. So I'm going to look at the limit as x approaches 2 of f of x. So just to double check, I see this as a fraction, which means it could have a problem area. So I'm going to plug in 2 to the denominator. So I get 2 times 2 squared minus 2 minus 1. If I plug in 2, I end up with 5 in the denominator, which means I can just plug in my x value. Remember, if you ended up with 0 in your denominator, then that's when you would have to factor it. So here I don't end up with 0 in the denominator, which means I can just plug in 2 for my x value. So I don't have to factor, because when I plug in 2, I'm not left with 0 in the denominator. So on top I get 4 plus 1. On the bottom I get 8 minus 2 minus 1, which is 5 over 5, which is 1. So if I see condition 1 was 1, condition 2 was also 1. So I could say steps 1 and 2 are equal, and since they're equal, f of x is continuous at x equals 2. So those are your like checklists. So 1, you're going to plug in f of whatever number. 2, you're finding the limit. 3 is kind of stating is it continuous or not. So let's try another one. So this same function we're going to see if it's at 1. So I'm going to plug in f of 1. So it would be 2 times 1 plus 1 over 2 times 1 squared minus 1 minus 1. So on top I would get 2 plus 1. On bottom I would get 2 minus 1 minus 1. So I would get 3 over 0. So right away, because I have a 0 on the bottom, I know that's undefined, which means it wouldn't be continuous because there's an asymptote there, because when the bottom is 0, that means it's a vertical asymptote. Therefore, I could stop right there, but just to double check, I want to see if the limit is undefined. So as the limit approaches 1 of f of x, now here I'm going to actually have to factor, because if I plug in 1, I would get 0 on the bottom. So the top does not factor. I'm left with 2x plus 1. On the bottom, it's 2x squared minus x minus 1, which means I could do borrow and pay back and then simplify. So I would be left with x minus 1 times 2x plus 1. So these would cancel. I would be left with 1 over x minus 1. If I still plug in 1, though, I notice I get undefined. So again, it cannot exist. So f of x is not continuous. And then we say at x equals 1. So that's kind of my checklist. I gotta check that the value of f of a is a real number. If it's not, like, undefined, then I know it's not continuous. Then I gotta check if the limit is also that same number. If it is, then it's continuous. If it's not continuous. So let's try one more together. So determine whether the function f of x equals x minus 2 over x squared minus 4 is continuous at 1 and then at 2. So for at 1, first step, we're going to plug in 1 for every x value we see. So 1 minus 2 over 1 squared minus 4. And again, just using my function, which is found up here. So 1 minus 2 is negative 1. 1 squared is just 1. 1 minus 4 is negative 3. So I would get 1 over 3. Then I'm going to check my limit. So if I plug in 1 into the x value in the denominator, I would get 1 squared minus 4, and that would just give me negative 3. So I do not need to factor it because my bottom wouldn't be 0. So the limit as x approaches 1 of f of x equals 1 minus 2 over 1 squared minus 4. So again, I would get negative 1 over negative 3, which reduces down to 1/3. So I notice that f of 1 is 1/3 and the limit is also 1/3. Therefore, both of my conditions are equal to each other. So f of x is continuous at x equals 1. So same number, it's continuous. Let's look at part 2. So it's saying at 2. So first step, I'm going to plug in 2. I get 2 minus 2 over 2 squared minus 4. So I would get 0. 2 squared is 4. 4 minus 4 is 0. So again, that's undefined, which means I know it's not continuous, but just to double check, I'm going to do the limit now. So here, since I plugged in 2 and I get a 0 in the denominator, I'm going to factor it. So on top, I can't factor that. On the bottom, though, it is dots. So I could do x minus 2 times x plus 2. That cancels. I'm left with 1 over x plus 2. Then I'm going to plug in what x is approaching, so 1 over 2 plus 2, and I get 1 over 4. So again, notice how condition 1 and condition 2 are not the same thing. I get undefined and 1/4. So my conditions are not equal. So f of x is not continuous at x equals 2. I suggest you pause the video now, try C. After you're done, come back to the video and I'll show you the answer really quick, and then you can start your homework. So here's your answer to part C. So for 1, it is continuous. For 2, it's not continuous. Write down any questions that you may have.